Good morning, grade 9s. We're looking at congruency of triangles. Go read through term 2 topic 3 document, pages 29 to 32 and 37 to 44 for more information. So firstly, the 4 conditions for proving a pair of triangles congruent are as follows. If you can prove 3 pairs of sides equal in each of the triangles, a side and any 2 angles, then a side, an included angle and another side, and then a right angle, hypotenuse and side. Specifically here, we've got to look out for that hypotenuse. So once again, use all your knowledge of triangle geometry and all other geometry to help you find missing angles, and so you can prove the triangles congruent. And then first you must start with the 2 triangles that you're going to work in. Once again, as sometimes we are working in more than 2 triangles in the diagram. We are not working in more than 2 diagrams. We are given more than 2 diagrams. So for every statement you need a reason, and if there's no reason for your statement, you will get no marks. So firstly here on the example 1, they're telling you PQ is equal to PS, and then PR is perpendicular to QS. And we've got to prove these triangles congruent, specifically triangle PQR and triangle PSR. As I can see 3 triangles. There's another triangle PQS, of course. But we're only working in PQR and PSR. And the first thing we can say is that angle R1 is equal to angle R2, because both of them should be 90 degrees, seeing that angle, we're told PR is perpendicular to QS, so both angles on both sides of the line segment PR would be 90 degrees. And then we're also given that PQ is equal to PS, so let's mark that on the diagram. PQ is equal to PS, and it helps you if you put it onto the diagram, because then in the big triangle, PQS, Q is equal to S. So I kind of wanted to start with that first. Okay, let's see. Then we have the side length PR is belonging to both of our triangles, and therefore it's called a common side. So we've got PQ equal to PS. And so I said I wanted to start in that first, but how I'm going to be specific, why, is I'm going to say angles opposite equal sides, and I'm going to mention in triangle PQS, because it's not especially in the triangle PQR and PSR. So now I can go ahead with R1 being equal to R2, and I'm going to mention that it's 90 degrees. Okay, and that reason is that it is given. Well, we can say PR perpendicular to QS, all given. And then we know that PR is equal to PR. Always remember, with congruency you need at least one side, and this is because it is the same side, basically the same line segment, but it's a common side to both triangles. So now we can proceed and say these triangles are congruent. PQR is congruent to triangle, and once again remember it's got to be in corresponding order. So we went along this way, PQR, so we've got to go PSR, then it's in corresponding order. Okay, and the reason for our congruency, we can go back and check. So we've got a side, PR is equal to PR. We've got another side, but very specifically, it's a side that is the hypotenuse in our triangle, and it's hypotenuse because we're working with a right angle triangle. So it is the right angle triangle. So if you shuffle these, you find that it is the reason of RHS, which is right angle hypotenuse, and one of the other shorter sides have been proven as equal. In example 2, we're proving that triangle AOB is congruent to triangle OCD, as you can see is inscribed into this circle over there. And they say O is the center of the circle and that AB is equal to CD. So I'm going to mark that onto the diagram. AB is equal to CD. But what we've also got to know, something interesting you might not have come across, is that this point being the center means that this measurement is a radius, and also then this measurement at OD is the radius of the circle. Isn't it then that any measurement that goes from the center of the circle to the edge of the circle, that line segment is referred to as any radius then? So isn't it also true then that the radius for any circle right around should be the same length, seeing that it goes from the center of the circle? So we've got therefore 3 equal sides. We know and have been given that AB is equal to CD, and then the radius OB is equal to the radius OD, the radius OA is equal to the radius OC. Okay, that's 3 sides. So we go ahead. AB is equal in length to CD, and that was information that was given to us. And then the OB length is equal to OD, and this information comes from knowledge that they are the radii of the circle. Okay, and so is it for OA and OC as well. They are the radii from the same circle. Okay, and therefore, seeing that we've got 3 sets of sides from the different triangles proven equal, we have triangle AOB. And I'm just checking the order quickly. So AOB, then it's got to be COD. Okay, so is congruent to triangle COD. And the reason, of course, we already mentioned is side, side, side. So you can have a look at the question. We've got question paper C2, question 2.3 and 2.5. Question paper F2, question 2.2. Question paper G2, question 2.3. Have a great day.